Hello, everyone, and welcome to Clay Loves Logic, where on this channel I solve logic-based Sudokus I find interesting. Today I'm going to be looking at the puzzle Binary Code by Ridhwan. As always, I'll put the link to the puzzle in the description of the video so you can try it if you'd like, but for now, let's get to the rules. Normal Sudoku rules apply. You have to have the digits 1 to 9 in every box, in every row, and in every column. Gray lines are palindromes that read the same forwards and backwards. Gray lines are also 10 lines. Each line consists of one or more contiguous groups of cells, each of which sums to 10. These groups of cells cannot overlap. So, this could be 1, this could be 9, something like that. Digits may repeat on lines and even within sums. Digits joined by a white dot are consecutive. That'll be this. 1, 2, 2, 3, anything like that. Digits joined by a black dot have a 1 to 2 ratio. 2, 4, 4, 8, anything of anything of the sort. Not all dots are given. Those are the rules. Let's take a look. So the first thing I want to do is color in the palindrome line that I'm going to be working on first, which is going to be this one. And what's interesting about this one is we know that these digits sum to 10 in some order. And one thing we know is because there's an odd number of cells on this line, odd number of digits, right? We have 2, 3, 4, 5, 6, 7. Because we have 7 digits on this line, there has to be a group that uses 3 digits, right? This could be a pair, this could be a pair, this could be a pair, and then what? We'd have to put a 10 on here, which we know we can't do. So there is, in fact, some group that sums to 10 that uses more than one, or that uses 3 digits, and it just has to be this one, doesn't it? Because how else do you use 3 digits that sum to 10? Well, these 3 digits are the same as these 3 digits. So if these sum to 10, these sum to 10. And if these and these sum to 10, this is a single 10, which is not allowed. So these 2 digits plus this sum to 10. And because these two are, it's effectively doubled, they have to be low, right? They have to be 1, 2, 3, or 4. Because if they're both higher than 5, we'd already kind of higher than 10. So if we have 4 and 4, that gives us 8. That would put a 2 here. 3 and 3 is 6. That would give us 4. 2 and 2 is 4. That would give us 6. And 1 and 1 is 2. That would give us 8. Now, the next thing I'm going to ask you is, in what world can this be a 6 or an 8? Because these are consecutive. This digit is consecutive with this. So 6 and 8 are removed. If we remove 6 and 8, then we have to remove the lower pairs because 1 and 2 now have to go. 6 pairs with double 2 to make 10. 8 pairs with double 1 to make 10. And now the question is that right? 6? Yeah. Yeah. And so then, because this has to be consecutive and there has to be an even digit, it just has to be 3 because 3 plus 3 is 6 plus 4 is 10. If this was a 2, well, 2 plus 3 and 3 is not enough. So that's how we start. And that gives us a 6. This digit is now a 6 because it's double 3. And now I believe we get to do the same thing on this palindrome. This palindrome is also 7 digits. And again, if we color them, I'm not going to color them to prove my point. But if we did color them, this and this would be pairs, or the same digit. This and this would be the same digit. So these would have to sum to 10, which means these have to be double 2, because 2 plus 2 plus 6 is 10. Otherwise, we get in that same thing where these 3 sum to 10, and these 3 sum to 10, and 6 doesn't sum to 10. That's just not possible. Okay, we'll have the same thing here. These 3 digits are going to sum to 10. And so we're going to need 2 low digits that aren't 3 or 4. So our options for low digits are 1 and 2, and double 1 plus 8 is 10, and double 2 plus 6 is 10. Those are the options as it stands. Okay, so now pink and blue have to sum to 10. Pink and blue could be 1, 9 pretty easily with no restrictions, or it could be 4 and 6. It could never be 3, 7 because there's a 3 in the box. If it was 4, 6, it's only 4, 6 if pink is the 4 and blue is the 6 by Sudoku. They both see the other 4 and the 6. So those are in fact our options. And now let's look at these two. We know that these sum to 10 and so do these. So I'm just going to, again, just briefly, I'm going to color these quickly just to illustrate one point. Sorry, I'll pick a different color. And my point is just this. This orange digit, if this is the low digit, it sees 2, it sees 3, and it sees 4. It could only ever be 1. And green also has the ability to be 1, and they both have the ability to be 9. So it is possible, oops, got rid of my coloring. It is possible that these are a 1-9 pair. Now I'm going to ask, could they ever be, well, what do we know? We know they're not 2-8 because all the digits see a 2. Green sees a 2, and so does rust, or whatever you want to call this. They both see a 2, so it can't be 2-8. This one sees a 3 and a 4. So it could never be. Well, actually, look, easier here. Orange sees 3 and 4. Green sees 3 and 4. So where would you put 3 or 4 if this was 3, 7 or 4, 6? And the answer is nowhere. So it can't be 2-8. It can't be 3. So this is specifically just a 1-9 pair. Which is interesting because now if we look at what these could be, look, this pink digit here, if this was 1 or 9, it would have to be one of them. But it can't be because this digit sees the rust color and the green color. These have lost their ability to be from 1 and 9. So they're just given. We've deduced that it's a 4 and a 6. And now I suppose we should make the 4s the same color. We might as well color the 6. I'm not, like I said, I'm not going to color everything, but a little bit of color. A little bit of color is fun. Okay, this digit and this digit are the same. What could they be? This digit and this digit are the same. What could they be? These two sum to 10, these two sum to 10. Until we figure out what it is, I'm going to just put a different color on. Okay, well, it can't be 1-9 pair because it sees both 1 and 9. Can't be a 2-8 pair because there's a 2 right here it sees. Both of these see the 2. It can't be 4, 6. They both see a 6. So it can only be 3, 7. And pink sees a 3. So purple digits are 3. And those are 7s. And for the sake of the puzzle, we already have a color assigned for our 3s. So we might as well just keep it up. And for fun, let's give blues a color as well. Why not? Okay, let's look down here. 1, 2, 3, 4, 5, 6, 7. The exact same thing happens, right? These are going to be a pair. These are going to pair. These 3 have to be summing to 10. And that's just the nature of the palindrome. And that just means that both of these have to be low digits and they're the same. And they can't be 2 and they can't be 3. So our only options here are 1 or 4. Double 1 would make this an 8. Double 4 would make this a 2. And if this was a 2, this could be the only spot where we'd have a 2. Okay, not necessarily interesting, but fine. Let's color these and these quickly. What have we not seen? Purple, maybe, from there. Okay. Oh, we'll have the same thing here, won't we? Can't be, these two digits are the same. And they could never be a 1-9. They can't be a 3-7. So these are both the low digits, and they're only 2 or 4. And then this is only ever 4 or 6. Yeah, double 4 is 8. Oh, no, sorry. Double 4 is 8. Okay, wait. Slow down, Clayton. This has to be a low digit. It can't be 1, so it's 3. If this is double 2, that sums to 4, so we need a 6. If this is double 4, that's 8. We need a 2. Those are the options. Okay. So that's interesting. There's always going to be a 2 on here Because if this is 6, these are double 2s. If this is 2, there's double 8s. But either way, this and this now have their maximum amount of 2s. So this could never be a 2. It could never be a 1. It could never be a 3. This only option for this to be a low digit is 4. And 4 would only put 8 here. What is this one's capability to be low digit? It can't be a 2, we know. Could be a 1. Oh, but no, because 1 would go to 2. So I think its only option is 3, 6, and only in this order. And now, oh, okay, well, look, just by coloring, this is a 1, 9, and it's the green 1, 9. And then we have to have a rust 1, 9 here and a rust 1, 9 here. That doesn't really mean anything yet. But that green, I feel like that's a useful deduction. What could this digit be? If this digit is the high digit or the low digit of the pair, it's only 1 or 2. 1 or 2 would make this 9 or 8. Both of those are fine. So this, for now, has the capability to be 1, 2, 9, 8. And so does this. Okay. Could this be and actually neither could ever be 3, 7 because there's a 3 in both rows already. And it couldn't be 4, 6. That's all this is. This is only ever 1, 2, 8, and 9. Okay. So whatever color those are, we're gonna need one of them up here. And we'll need so this brown digit, this whether this is 1, 2, 8, or 9, it goes here. Is that interesting just yet? And the answer is I don't know. So let's look somewhere else. Well, a 3 could only be in one of 2 places. And a 3 could never be there. So there's always a 3 up here, which means there's always a 3 somewhere here in the middle. Not really that interesting. There's always a 3 there, and then there's always a 3 here. Yeah, that's not really that interesting, unfortunately. Oh, 7. Look, we have a naked single. This is 7 because you have to have a 7 in this row, and it can't be here or here. Okay. Well, there's a digit. A little bit of progress. Think. Brain, where do we look next? We have to have a 6 somewhere here, which means we have to have a 6 somewhere here. Which, again, not terribly interesting. It's interesting in the sense that we also have to have a 6 somewhere here, which means in this box, the 6 is somewhere down here, which, again, doesn't really feel like much of a win. Truly. Oh, I guess you know what? Also 7. This is a 3, 7 pair in some order because, again, 7 can't be here. Okay, well then actually, what's this now? Because look, we have a 1, 9 pair, we have a 3, 7 pair, we have a 4, 6, we have a 2. So this is only from 5 and 8. Again, it doesn't really do much for me. I guess we know that 5 and 8 have to be here. But yeah, that's not really helpful just yet. Are these always one? What do we need here? 1, 2, 8, 9, and 5. Boy, I wish I knew what color of if this was 1, 9 or if this was 2, 8. I guess that could never be a 2, so this could never be an 8. So This could never be an 8, and this could never be a 2 because of this 2. Okay, well, let's think about this for a second. If this is 2, these are both 4. And that means these are 9 and 1. If this is 8, these are both 1. Oh, that does it. That's been available for ages. Look at that. This can only be a 2 or an 8. In what world could this be an 8? If this is an 8, these both have to be 1. And now this can't be a 1, 9 or a 2, 8. So this is only ever 2, and it's blue. And that is going to do so much, I almost can't speak. I'm so excited. This will be, in fact, a 4. That is going to give us a whole load of stuff. And it starts up here, because this 2 sees these. These are both 1s. 1 plus 1 is 2, of course. So plus 8 gives us 10. Now these both have to be 2, which means this has to be 6. So this has to be 4, and this has to be 8. And again, we could do that because we knew that these were 2s, because this was a 4. 2 plus 2 is 4, plus 6 is 10. This has to be 4. This is now 8. Okay, great. We have to have a 4 here now. We can just see by Sudoku, where do you put a 4? It's not there or there. It can only be here. And because of these ones, right? So we need to have a 4 somewhere up in the top 3. It can't be in this row or this row. So this is a 4. Oh, and look, this 1 solves the 1, 9 pair, right? These now have to be 9. These have to be 1. So this is a 1. Okay, and look, this 9 sees this. So these are both 1. And 1 is not brown, 1 is green. These are both 9, which is not purple. It is, in fact, this rust color. Great. Okay. Excellent. 6 is blue. Not that it really matters at this point. It just looks nice. It just looks nice. Ooh, ow, crap. I just got tattooed a week ago, and I'm very itchy. And I scratched my tattoo, which is a big naughty thing to do. Not ever supposed to do that. Okay, what are these 3 digits? 1, 2, 3, 4, 5, 8, and 9. This is never an 8 because there's an 8 in the box already. So this is an 8. Interesting enough. And this is 5 and 9, and this 9 sees this. So this is 5, and this is a 9. And now the remainder of digits left in this box are 1, 2, they're 3, and they're 7. And we don't know in what capacity they're 3 and 7, so I'll just pencil mark. Here in the middle, we're going to need 4, which is only ever here. We're going to need 5, which we don't know where it is yet. And we're going to need 9, which we do know. By Sudoku, that's 9, and that's 5. So now we've colored in we've solved all the palindrome lines, so I think it's just going to be Sudoku now. So let's just look at the digits. 1, 1, 1, 1. So we get a 1. 1, 2, 3, 4, 5, 6, 7, 8. We need one more 1, and it's in the middle. All the 1s are done. This is a 2 by Sudoku. 2 is in one of these spots. 2 is in one of these spots, and 2 is in one of these spots. On to the 3s. Nothing on the 3s yet. What about 4s? 1, 2, 3, 4, 5, 6. We have all the 4s done. There's not many 5s. I'm not going to look at them yet. 6s. 1, 2. Yeah. What about 7s? Are 7s interesting? No, they're not. Not yet, at least. 8s are, in fact, also not interesting. And then 9s, well, 9s are a little interesting. We get a 9 here by Sudoku, which is going to give us the ability to put a 9 here by Sudoku. And then 9 is in one of these spots. So now this is a 3-9 pair, because 9 can only be here and 3 can only be here. So this can no longer be a 2, which means we get a 2, we get a 2, we get a 2. Excellent. Okay, what else can we say about 9s? 1, 2, 3, 4, 5, 6, 7, 8. Oh, and there's a 9 here. So in fact, this is 9, this is 3, and we know that that is that. Okay. Well, now we're really moving. We're really moving in this puzzle. Let's look at the 1s again, because now we've cleared up some things. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, the ones are done. I just don't have them all colored. Let's just just color them for simplicity's sake, so we can see it a little easier. All the ones are done. What about twos? 1, 2, 3, 4, 5, 6, 7, 8, 9. The twos are done. Threes. 1, 2, 3, 4, 5, 6, 7. Oh, well, there, that does it. Where do you put a 3 in here? In this box? Well, it can't be here and it can't be here. It's in one of 3 spots. Where do you put it in this box? And it has to be in the bottom row, which means we get a 3, which is going to resolve this. That'll give us a 3, 7. And we'll just scrap the colors. That's going to give us, well, not much more yet, but yeah, not much more yet. If we look at this, well, okay, so 7 can't be in this row, so 7 has to be up here. And 7 has to be here or here. And then 7 has to be here or here. And it has to be... It's not as interesting. 8 in one of 2 spots. Oh, a naked single. Where does 8 go? Right? We need an 8 in this box somewhere. It doesn't go here. This is only ever an 8, so this is an 8. This is no longer an 8. And this has lost its ability to be a 6 because it is now an 8, which is going to do a few. It's actually going to do a lot of stuff, because now look, where do you put an 8 in this box? Only put it there, which means you can only ever put a 6 here because that's the color for 6, which means this is a 7 and this is a 7, and this is no longer a 7. This is now a naked single. It is 5, which is going to resolve the 8 and the 5. Up here, we're going to need a 5, which is here by this 5, and an 8, which is here. In this row, we need a 6 and a 5, don't we? Isn't that all? And look, this can't be a 6. So this is a 6, this is a 5, and we'll just get rid of the color. So what do we need here? 1, 2, 3, 4. We need a 5 somewhere. It's only up here. And so it's not that. And then this is going to be 8, naked single, obviously. Up here, we need 1, 2, 3, 4, 5. We need 6 and 7. And surprising. Oh, that does resolve, because look, where does 6 go? Can't go here anymore. This is a 6, if I could type. So this is a 6. This is a 7. This is a naked single. I'm betting it's 5. We just didn't have any 5s on the palindrome. It is 1, 2. We need 3s and 7s. So this sees that 7s. This is 3. This is 7. This is 3. This is 7. And finally, we need a 5 and an 8, and we're going to get, or sorry, a 5 and a 6, and we're going to get that in this order. Great puzzle. You solved the puzzle. The solution is correct. 61 people solved in 8.7 hours, 24 minutes, and 9 seconds. I did like this puzzle. Very fun puzzle. I'm going to just get rid of all the incomplete coloring that we don't need. I know. Yeah. Really fun. That was a really fun puzzle. Thanks for tuning in, everyone. Catch you on the next one.